This will be a quick tutorial on how to do a two-sample z-test for a difference of means using GeoGebra. So I've got GeoGebra open here on the left, and I have a problem on the right-hand side that's giving me some independent sample information. Notice that I'm given the population standard deviations sigma over here in my summary table. So since I know sigma, and my sample sizes are large, I have independent samples, and I want to test these hypotheses, mu1 equals mu2 against mu1 greater than mu2. So that's going to be a two-sample z-test for a difference of means. Using GeoGebra, since I have my statistics, I'm not starting from raw data. I'm going to go to the probability tab and then the statistics calculators tab. Now this is a two-sample test, so I need to find the correct testing calculator. In this case, it's going to be a z-test for a difference of means. The null hypothesis by default is that the difference is 0. That's what I want here. And my alternative is right-tailed, mu1 greater than mu2. So I need to set the alternative hypothesis to the correct direction. Now I'm going to fill in my information that I have in the tables for sample 1 and sample 2. Okay, so I filled in all of the information from the two samples. I have sample 1 and sample 2, just like I have them in the table here. Note that the order that I put them in matters. Since I'm given my null and alternative hypothesis, my assignment of population 1 and population 2 has to be consistent with that. So as I entered that, I saw the test results populate down here. I have the standard error of my sampling distribution, and I have my z-test value, which is a positive value, which is what I expect in a right-tailed test. So let's put that in where we are asked for the z-test statistic. The test statistic in a z-test means the z that is computed as a result of the sample data. We also have the p-value. So we'll enter the p-value where that's asked for. And let me jump back up here to part A. The test, given the alternative hypothesis, I can see is a right-tailed test. So my p-value is 0.14 and change, and my alpha is 0.10. Be careful, it's easy to misread those alphas sometimes. So 0.10 is my alpha. My probability p-value is 0.14. That is greater than alpha. Alpha is my threshold of disbelief. This probability is not so low that I'm willing to disbelieve the null hypothesis, and therefore I will fail to reject the null.